Change is literally happening all around us, all the time. Some of it's big and obvious, some of it's really small. But have you ever stopped to think about what's really going on? Today, we're going to put on our detective hats and investigate the secret lives of these changes to figure out how our world actually works.
Okay, so every good investigation needs some evidence. Let's start with Exhibit A, a simple ice cube. You leave it out, and pretty soon you've got a puddle of water. Something's clearly changed, right? But what kind of change are we actually looking at here?
All right, on to Exhibit B. You take a normal piece of paper and you just snip it in half. You started with one piece, now you have two. So yeah, it's different now, but is this the same thing that happened to the ice? Let's get one more clue, just to be sure.
And for our final piece of evidence for now, let's look at a shiny iron nail. If you leave it outside, it slowly starts to get those familiar, kind of flaky, brownish red spots. We all know it as rust.
So here's our big mystery. We've got melting, cutting, and rusting. 3 totally different results. But are they all just different versions of the same thing? Or are we dealing with completely different kinds of transformations here? Okay, let's start digging into the evidence.
Let's start with our first category of change. Think of this one like a suspect who's a total master of disguise. It might look completely different on the outside, but deep down, it's still the exact same thing.
So let's look at the evidence. You can fold a piece of paper into an airplane, but you can just unfold it, right? It's still paper. You inflate a balloon, and the rubber just stretches out. You crush a piece of chalk, and you just end up with tiny little pieces of, well, chalk. The key here is that the stuff itself, its identity, hasn't actually changed at all. And that right there is the smoking gun for this type of change. Yeah, the look is changed, the shape, the size. Maybe it went from solid to liquid, like our ice cube, but what it's made of, exactly the same. Nothing new was created. And that brings us to our official definition. We can now confidently slap a label on this one. It's a physical change. It's all about the disguise, changing how it looks, but never ever what it actually is.
Okay, but some changes, they're not just a disguise. Our next suspect is a true shapeshifter. We're not talking about a new outfit here. We're talking about a completely new identity.
Now, to catch this identity swapper, we're going to need a special technique, the lime water test. And it's actually super simple. All you do is take 2 glasses, one with regular tap water, the other with something called lime water. Then you just breathe out through a straw into each one. The result is pretty wild.
And here's the payoff. The tap water? Just some bubbles, nothing really happens. But look, the lime water, it turns all milky. What just happened there? Well, the carbon dioxide from our breath had a chemical reaction with that lime water and created something brand new. A new substance was formed. And that right there is the game changer.
This brings us face to face with our second suspect, a chemical change. This isn't just a new look, it's a total transformation where the stuff you started with literally rearranges itself into something completely new, through what we call a chemical reaction.
And the clues for a chemical change? They can be pretty dramatic. Remember that rust on the nail? Yep, that's a new substance called iron oxide. Or that fizzing when you mix baking soda and vinegar. That's a whole new gas being created. And the bright light you get from burning magnesium? That's a classic can't-miss-it sign of a chemical reaction. All right, detective, so we've got our 2 main suspects profiled. The physical change, our master of disguise, and the chemical change, the identity swapper. Now it's time for a real-world case that's going to put your skills to the test. Let's call it the candle conundrum. So, take a look at a burning candle. You see the wax melting, you see the flame. What do you think? Is this a physical change, a chemical one? Or, and here's the twist, could our 2 suspects be working together on this one?
Okay, let's break it down. First, just look at the wax right near the flame. It's melting, right? Going from solid to liquid, but it's still wax. If you were to let it cool down, it would just turn back into solid wax. Nothing new was made. That's a classic textbook physical change.
But wait, that's not the whole story, is it? That liquid wax gets sucked up the wick, turns into a vapor, and then, boom, that vapor burns. And that burning gives off heat and light and creates totally new stuff like carbon dioxide. That, my friends, is a definite chemical change. So, what's the answer? It's both.
So, the candle case proves that physical and chemical changes can happen at the same time. But it also brings up another question. We know we can let that melted wax get hard again, but can you unburn the wick? Probably not. And that brings up a whole new line of inquiry. Are these changes something we can undo, or are they forever?
So if you look at this, a pattern starts to emerge. A lot of physical changes, they're reversible. You can freeze water back into ice, no problem. But most chemical changes? Nope, they're permanent. I mean, think about it. You can't unpop a piece of popcorn or unbake a cake. The new stuff is here to stay.
Now that we've kind of mastered these changes on a small scale, let's zoom way out. Let's go big picture and see how these same two types of change, working over millions of years, can actually shape our entire planet.
Take a look at something like weathering. That's basically just big rocks breaking down into smaller ones. Sometimes it's physical, like when water freezes in a crack and splits a boulder. But it can also be chemical, like when rainwater slowly reacts with minerals and changes what the rock is made of. And then erosion, which is mostly physical, just has wind and water carry all those little bits away.
And what's the incredible result of all this? Well, it's the very ground we're standing on. The soil we need to grow our food is literally created by these non-stop physical and chemical changes happening over millions and millions of years. It's a pretty wild reminder that even the tiniest changes can, well, build a world.
And with that, you are now officially a change detective. You're ready to spot the hidden physics and chemistry that are transforming the world all around you. So as we wrap this up, I'm going to leave you with one last thing to think about. Right now,